460 kilometers above the Earth. Here, in the silent black vacuum of space, two objects are closing in on one another. They're not asteroids, not debris. They are sophisticated machines, performing a ballet of immense speed and almost unbelievable precision. Right now, their orbital velocity is just staggering, 28,800 kilometers per hour. To put that in perspective, that's nearly 8 kilometers every single second, a speed 10 times faster than a bullet from a high-powered rifle. And yet, as they get closer for that final rendezvous, their relative velocity slows to a crawl, just 10 millimeters per second. This is the great paradox of orbital mechanics, a high-speed chase that has to end in one of the most delicate and challenging maneuvers in all of spaceflight. But, this isn't just some technical demonstration. Mastering this orbital handshake is the key. It's the foundational capability for humanity's permanent expansion beyond our home planet. You see, to establish any kind of lasting presence in orbit, we run right into a fundamental law of physics and engineering. You just can't launch colossal structures in a single piece. They have to be assembled up there, in space, module by interconnected module. So really, the history of our life in orbit is a history of construction. Think about it, from the very first Salyut station all the way to the sprawling International Space Station and China's modern Tiangong, every single one has been a monumental assembly project, needing dozens of precise docking maneuvers just to bring them to life. And now, a new chapter in that story is being written. India is pursuing its own major ambition to construct its own modular outpost, the Bharatiya Antariksh Stati. And this entire strategic goal depends completely on mastering that art of orbital assembly. Just as ISRO Chief S. Somanath outlined, the whole path to a space station is built on having your own sovereign docking capability. So this national ambition created an urgent technological need. The mission designed to answer that very call is the space docking experiment, or as it's known, SpaDeX. It's a technology demonstrator, sure, but with strategic implications that go far beyond its immediate goals. So what is the core challenge here? Well, it's this intricate, multi-stage process of guiding two spacecraft, both hurtling around the planet, into the exact same orbital path, aligning them perfectly, and then physically joining them so they become one single unified entity. This mission has two main characters in its orbital ballet. First, you have STX-01, the chaser satellite, which does all the active maneuvering. And then you have STX-02, the target satellite. These twin 220-kilogram satellites were launched together, placed into a 460-kilometer orbit. And right there, the stage was set for one of India's most complex, autonomous missions ever attempted. Now, actually executing this maneuver, well, it requires a perfect symphony of orbital mechanics, autonomous navigation, and some extremely precise engineering. The whole process unfolds in 4 critical phases. First up is rendezvous, where the chaser has to perfectly match the target's orbit. Then, proximity operations begin, closing that initial 20-kilometer distance down to just a few meters. In the final approach, advanced sensors take over, guiding the chaser with microscopic precision. And finally, capture and docking, where a physical mechanism engages to form a solid, secure link. So how is this even possible? Well, it's all down to an extraordinary suite of sensors. It starts with a laser rangefinder that is constantly and precisely measuring the distance between the two spacecraft. That data is then supported by a rendezvous sensor, which calculates the exact relative position and velocity vectors. Basically, it gives the onboard computers a complete picture of where they both are in three-dimensional space. And all the while, an inter-satellite communication link lets the two autonomous craft talk to each other, sharing vital orientation and location data in real time. This is absolutely essential for them to move in perfect coordination. But at the very heart of the experiment is the Bharatiya docking system. This is an indigenously developed androgynous mechanism. Now, androgynous just means that both connecting ports are identical, which allows either spacecraft to initiate the link. It's a design based on international standards, but it's specifically engineered for a very low-impact capture. It all comes back to this incredible paradox, doesn't it? To join two objects that are traveling at nearly 29,000 kilometers an hour, you have to slow their relative motion to less than a snail's pace. It's an incredible feat of engineering that SpaDeX was designed to prove. And if you find these deep dives into the science that is shaping our global future valuable, please consider supporting our work by liking and sharing this analysis. With the success of this mission, India didn't just test a new piece of technology. No, it joined a very exclusive group of spacefaring nations. You see, the ability to perform autonomous rendezvous and docking is a capability that has been mastered by very few. With this achievement, India became only the fourth nation in history to develop and demonstrate this incredibly complex technology all on its own. This places the SpadeX mission in a direct line with some of the most historic moments in spaceflight history. America's very first docking with Gemini 8 way back in 1966, the Soviet Union's automated success just a year later, and China's powerful demonstration in 2011. But the real significance of this achievement isn't just about joining an exclusive club. It's about what this capability unlocks for the entire future of exploration. Let's be clear, docking is not an optional extra. It is the fundamental prerequisite for nearly every ambitious deep space endeavor that's being planned for the coming decades. This single technology is what enables the construction of modular space stations. It's absolutely critical for assembling deep space vessels like the Lunar Gateway. It opens the door to on-orbit servicing and refueling of satellites, and it's the basis for active debris removal and, one day, future interplanetary transport hubs. And beyond its main goal, SpaDeX also successfully demonstrated the transfer of electrical power between the two docked spacecraft. This is such a vital step because it proves that future modules can share resources and operate as a single, integrated system. This successful demonstration moves docking technology from the world of experiment to the foundation of future infrastructure. It enables concrete plans and opens up completely new economic possibilities. Because the technology has now been proven, the roadmap forward becomes tangible. The first module of the Bharatiya Antariksh Station is now targeted for launch in 2028, with the planned completion of the entire station by 2035. This is the long-term strategic vision that a single experiment like SpadeX makes possible. This capability is truly the foundational technology for an emerging on-orbit economy. Whole industries centered on satellite servicing, orbital logistics, debris removal, and in-space manufacturing are now shifting from just a concept to a commercial reality, all built on the mastery of autonomous docking. All of this leads us to a final, pretty provocative question. As this technology becomes more common, more autonomous, and more accessible, how will it fundamentally reshape our entire presence in the cosmos? When we look back, I think the silent, precise dance of those two SpaDeX satellites, 460 kilometers above our heads, will be seen as something much more than just a successful technical trial. It marks a fundamental transition. We are moving beyond merely visiting space, and we're finally learning how to build a lasting presence among the stars. To continue exploring these critical intersections of geopolitics, science, and technology that will define our future, subscribe to Global Apex Arena.